So a graph is a pictorial representation of the relation between two sets of data, of which one set is of dependent variable and other set is of independent variable. So one set is dependent variable. We know that time is independent. We always place time along x-axis, and velocity, displacement, they are dependent quantities. So they are placed on y-axis. Quantities that can be calculated using graph is one by finding slope of the curve and other by finding area under. The quantity that we find by slope of the curve is, we simply divide y and x, y2 minus y1 upon x2 minus x. This is what we do. And we get the quantity which comes by dividing the quantities that we have already on the graph. For example, as here we have velocity and time. So when we divide velocity and time, we get acceleration. So slope of this graph will give acceleration. And when we take area under curve, we multiply the quantities. So area under curve gives the, in this case, BT graph, it gives the displacement. When you multiply velocity and time, you get displacement. So area under curve also gives the displacement. Now from a graph, we can find two different quantities. Okay. By finding slope of the graph or by finding area under curve, we can find two different quantities. Now please write this in your notebook. This is important. See, first thing is that we can find area under curve. Area under curve. See, this axis is the y-axis, right? And this is origin and this is x-axis. We always take independent variable on x-axis and dependent variable along y-axis. So v is the dependent variable and time is the independent variable. Okay. So area under curve is the first thing that we can find from the graph is area under curve. Suppose we want to find, from T1 to T2, the displacement. So in velocity time graph, we can find displacement by finding area under curve. Okay. In velocity time graph, we can find displacement by finding area under curve. So you'll find the area of the shaded region, and area of the shaded region gives the displacement in this time interval T1 to T2. So this why displacement? कहाँ से आया ये displacement? कैसे आया ये displacement? This is the question. See, we have velocity time graph. Whatever we get, see, when we find area under curve, the quantity that we get is by multiplying y and x component. Okay, so y component along y-axis, we have velocity. And here, for example, in this case, in this case, we have along y-axis velocity and along x-axis we have time. So when we multiply velocity and time, we get displacement. What is displacement? Velocity is displacement upon time, right? Velocity is displacement upon time. So displacement is velocity into time. ठीक है, displacement is velocity into time. तो अगर आप इसका एरिया अंडर कर्व निकाल रहे हो तो वो क्वांटिटी मिलेगी जो y एक्सिस में जो क्वांटिटी है और जो x एक्सिस में क्वांटिटी है, जो उन दोनों को मल्टीप्लाई करके आती है, वो क्वांटिटी हमें मिलती है फ्रॉम एरिया अंडर कर्व. ठीक है. अब सिमिलरली वी कैन टेक एनी अदर एग्जांपल. लेट्स टेक, और कौन सी क्वांटिटी ले सकते हैं? सपोज वी हैव, लेट्स से वी हैव 80 ग्राम. So here we have acceleration and here we have time. ठीक है, तो acceleration and time. So this is the curve that we get. So when we find area under curve for an 80 graph, A is the acceleration and T is the time, then which quantity do we get? By finding area under 80 graph, acceleration time graph. What quantity do we get by multiplying area and acceleration? See, ध्यान से सोच के बोलो. See, what is acceleration? Acceleration is v minus u by t. So when we multiply a and t, what do we get? Velocity. So by finding area under this curve, we get velocity. So area under acceleration time graph gives velocity. Area under velocity time graph gives acceleration. Easy? Okay. There are other quantities also, but I'm not taking those examples because you know you are not familiar with those quantities, with those relations. So we'll discuss जब हमारे पास जैसे से topics आएंगे ना, when we'll do change in momentum upon time dp by dt, there also you can find area under curve. The second quantity using graph, that slope. By finding slope, we can find the another physical quantity. Okay. Now, how do we find slope? For slope, we take two different points on the curve. Anywhere you can choose. You can choose P and Q, your points. You can, any 2 points can be chosen. Okay, of your choice. That's your wish. At which point you want to choose. Okay. So we take two different points and let the coordinates of this point be x1, y1. You have done coordinate geometry. Have you done? And coordinates of this point be x2, y2. So our x1 is t1 actually. In this particular case, x1 is t1 and x2 is, sorry, y1 is v1. No? It's along y-axis. This is ordinate and this is abscissa. And here x2 is t2 and ordinate is y2 is v2. Okay, and how do we find slope? Slope is y2 minus y1 divided by x2 minus x1. Okay, this is how we find slope. And there is one more way of finding slope. We just draw a line which touches the curve at some point, at one point, and the angle that it makes with the x-axis. Tangent of this angle gives the slope. We'll do trigonometry in class 10, then you'll get to know in a better way. Okay, so slope can also be found out using this. It is equal to tan theta. So we can either find tangent of this angle or we can use this formula for finding slope. Okay, so in this particular case for VT graph, for the given VT graph, we have slope is equal to, what is y2? It's v2 and y1 is v1, x2 is t2 and x1 is t1. So it's v2 minus v1 upon t2 minus t1 for this particular graph. So when we divide v and t, we are dividing y and x, na? In area under curve, we get the physical quantity by multiplying the quantities that we have. Okay, and here in this slope, the quantity that we get is by dividing the physical quantities y and x. एरिया में क्या किया था? एरिया में ये किया था कि y और x को मल्टीप्लाई करके क्या, और स्लोप में हम क्या कर रहे हैं कि y और x को डिवाइड करके क्या. This is the difference. So in VT graph, when we multiply v and t, we get displacement. But when we divide v and t, then we get acceleration. Yes. Then we get acceleration. Na? So the quantity that we'll get is acceleration here. So we get acceleration by finding slope of VT graph. And suppose in case of this VT graph, we have displacement time graph. Then what? If we have a displacement time graph. So here we have displacement. It is measured in meters. It is the dependent variable. So it is along y-axis. And time we always take along x-axis because time is the independent variable. And this is the graph that we are getting. So we can choose 2 points on the graph. Okay, let the coordinates of this point be. This is t1. At time t1, displacement is x1. And at time t2, displacement is x2. So what are the coordinates? We write t1 first, abscissa, and then ordinate. And here also, first we'll write abscissa and then we'll write ordinate. So when we find slope of displacement time graph, we use the formula y2 minus y1 upon x2 minus x1 only. So here we subtract ordinates and then we subtract abscissas. In ordinate, we have x2 minus x1 and abscissa is t2 minus t1. this is displacement upon time. When we divide displacement and time, we get velocity. So slope of displacement time graph gives velocity. Okay? Acceleration time कराओ फिर होगा तो acceleration upon time आएगा अगर slope find करते हो तो you get another quantity which is not velocity or displacement, so something else. You'll get dA by dt, that is rate of change of acceleration. Okay. For a stationary object, this is the graph, straight line parallel to time axis. For uniform motion is yes, if the object covers equal distance in equal intervals of time, then it is uniform motion. Okay. So if equal distance is covered in equal time, means speed is constant in uniform motion. Object is moving with constant speed. And this is the graph that we get. So on y-axis, again, the same way we'll write the distance, and here on x-axis we'll write the time. You can see distance is in kilometers in this case, and time is in minute. The slope of this distance time graph gives the speed. Slope of distance time graph gives the speed. And how do we find slope? So we have chosen, you can see 2 points here, S1, S2, and T1, T2. Are these points visible? No. So this is your S2. Okay. And this is S1, and this is T2, and this is T1. So we have chosen these 2 points. No, it's not 60. It is, it is just close to 60, but it is not 60. Okay. So we can find slope of this graph. When we find slope of the graph, how will you find slope? Using this formula, S2 minus S1 upon T2 minus T1. By finding slope, you get speed. Okay. So we can see that every time object is covering equal distance in equal time. This is the case of uniform motion. You get a straight line inclined to time axis. So in the previous case, we had a straight line parallel to time axis. When the object was at rest, it was not moving at all. There also we had found out the speed, and speed was 0. But here in this case, we will not get speed as 0. Speed is not 0, but we are getting a graph again straight line, but this time it is inclined to time axis. Okay. Now look at this. What do you observe? We have 2 different cars. One is blue in color, other is red in color, and they are moving with different speeds. So you can look at these graphs now. What do you conclude from these graphs? It is moving faster. The one which is moving faster has both are executing uniform motion. Both are undergoing uniform motion. We are getting straight lines for both. Blue and red, for both we are getting straight lines, means both are moving with uniform speed. They are moving with constant speed. The only difference is one is faster than the other. So we find a slight difference between the graphs. You can see one graph is more inclined than the other. So which graph has greater slope? Red one has the greater slope. It is making more angle with x-axis. It has the greater slope. So greater slope indicates greater speed. Greater slope means it is moving with greater speed. ठीक है, जिसकी स्पीड ज्यादा होगी उसका स्लोप ज्यादा आएगा, उसका जो एंगल एक्स एक्सिस के साथ बनेगा वो ज्यादा बनेगा. ठीक है, इसमें कोई डाउट है? For non-uniform motion, we get curved line. So when the speed increases with time, then we have increasing slope like this. So if you just draw, when the speed increases with time means speed increases with time, मतलब speed बढ़ रही है उसकी, तो हर बार जो है it is covering more and more distance as compared to the previous time interval, greater distance as compared to the previous time interval, then we get the increasing slope like this. Okay, but it is a curved line. Curved line shows that speed is not constant. Speed is increasing, na? It is not constant. Okay. And when the speed decreases with time, then we get the curve like this. So this graph represents decreasing slope. Increasing slope is like this, decreasing slope is like this. Draw these two curves now. अच्छा इसको ना you can इसको आप ग्राफ में से भी अंडरस्टैंड कर सकते हो. देखो if you find the distance ना, I'll show you how. Let's choose a specific for a particular time interval. If we take na this, let's keep time interval same, and keeping time interval same, I'm going to find just locating the distance for the fixed time interval. So I'm keeping this t fixed. These look equidistant na, these points on t time axis. मैं ट्राई कर रही हूँ कि ये इक्वल इक्वल आए, ठीक है. फिर हम देखते हैं कि डिस्टेंस में कैसे वेरिएशन आ रहा है. अब देखो, every time for a fixed time interval we are getting greater value of distance. नहीं आया. अच्छा अभी मैं इसका बनाती हूँ, फिर आप कंपेयर करना. जैसे अब हम इसमें हम इतना ले रहे हैं ना गैप, हम इतना इतना नियरली इतना ले रहे हैं, राइट. नियरली इतना गैप ले रहे हैं ना. इतने गैप के लिए I have drawn this vertical line and this horizontal line. This vertical line is for the time and this horizontal line tells us about the distance, right? Ab I'm just taking another line, vertical line. This is for time and this is for distance. Yes. Let's choose one more. This is for time and this is for distance. One more. Yes. Now look at these two graphs. What difference do you see between these lines? बताओ क्या ऑब्जर्व कर रहे हो, क्या लग रहा है आपको, क्या डिफरेंस है. यहाँ पे जो गैप था डिस्टेंस का, इनिशियली इट वाज वेरी स्मॉल एंड इट इज इंक्रीजिंग ना. दिस गैप इज इंक्रीजिंग. 1 सेकेंड में ऑब्जेक्ट ने ज्यादा डिस्टेंस कवर किया और उसके बाद 1 to 2 में थोड़ा और कम, 2 to 3 में और कम. इसका मतलब क्या हुआ कि स्पीड जो है उसकी कम हो रही है, वो स्लो होता जा रहा है, तभी वो कम डिस्टेंस कवर कर रहा है ना. फिर 3 to 4 में और कम डिस्टेंस कवर किया है, तो स्पीड जो है उसकी वो क्या हो रही है, डिक्रीज. स्पीड इज डिक्रीजिंग विद टाइम, एंड बिकॉज speed is decreasing with time and therefore it is covering less distance in the same time interval. It is covering less distance. So this shows speed, decrease in speed or decrease in slope we have. But here in this case we can see, in this case initially in 1 second object has covered this distance, small distance. In 2 seconds object has covered this distance. Yes, in 4 seconds object has covered this distance. In 3 seconds object has covered this distance. So this shows increasing slope because यहाँ पे distance कम cover हो रहा है 2 to 3 seconds में, और 3 to 4 seconds में object has covered greater distance. It is moving faster and therefore it has covered greater distance. तो greater distance मतलब faster move कर रहा है, तो यहाँ पे speed क्या हो रही है, increase हो रही है, और यहाँ पे speed क्या हो रही है, decrease हो रही है. ठीक है. Next, now we know what do we get from slope of ST graph. Now you tell me. Distance time graph. If we have a distance time graph, then what quantity do we get by finding slope of distance time graph or displacement time graph? See, we have displacement time graph. When we divide displacement and time, we get velocity. And when we divide distance and time, we get speed, right? So we get speed. Now, out of A and B, which one is moving with greater speed? A or B? A is moving with greater speed. Why? It has greater slope. Greater slope indicates greater speed. Now look at this graph. So can you find velocity using displacement time graph? For curve A and curve B. So both the curves we are finding slope. Okay. So let's find for graph A first. Object A. Let's find slope for object A first. So we'll choose 2 points of as per our convenience. Let's choose these 2 points. So what are the coordinates of this point? First we write abscissa and then we write ordinate. It's 1 and 40. And coordinates of this point? 3, 120. So slope of speed of object A. How will you find speed of object A? कैसे करोगे बताओ? S2 minus S1 upon T2 minus T1. So it is, what should I write now? 120. Y2 minus Y1. Na? First we take ordinate and then we subtract abscissa. So 120 minus 40 upon 3 minus 1. 120 minus 40 is 80 upon 2. What will you get? 40 meter per second. No, it's not meter per second. It's kilometer per hour. Because displacement is in kilometer and time is in hour. So its unit is kilometer per hour. Now let's find speed of object B. Speed of object B. Again, we'll choose 2 points. Let's take this point and this point. Find the coordinates. Yes, it's 2, 80 and coordinates of this point 4, 120. Okay, now what should I write here? 120 minus 80 and in the denominator we'll write 4 minus, see it's 2. 4 minus 2. So what will you get? 40 divided by 2. Speed is 20 kilometer per hour. So which one is moving faster? Object A is moving faster. And B is moving slower. And one more thing. The angle that object A makes, this graph makes with x-axis is greater than this angle. This angle is greater than this. So this has greater slope. Greater slope is more speed. Yes, this is how we find speed. And one more thing. तो ये ऑब्जेक्ट ए जो है इसको ओवरटेक कर रहा है ना एट सम पॉइंट बी को कितने डिस्टेंस के बाद और कितने टाइम के बाद ये बी को ओवरटेक कर रहा है at a distance of 80 kilometers and after 2 hours. After 2 hours. 2 hours के बाद 80 किलोमीटर के डिस्टेंस पे जो ए है वो बी को ओवरटेक कर रहा है तभी यहाँ पे ये क्रॉस कर रही है लाइंस. ठीक है, बिकॉज ये ओवरटेक कर रहा है इसलिए क्रॉस कर रही है लाइंस. समझ आ रहा है? करो. We have these, you can see different lines here, different colored lines here. Okay, so these 2 lines, the blue one and the green one, they represent constant speed. It's a displacement time. So these 2 lines represent constant speed. Okay, so object is moving with constant speed in these 2 cases, but one is moving faster than the other. Which one is moving faster? Green one. Green one is the object with this, motion is moving faster than this. And this line, which is parallel to from 5 seconds to 9 seconds, we can see that there is no distance covered by the object. So this line represents object at rest. This line represents stationary object. Object is not moving at all because we can see the line parallel to time axis. And in this case, it is uniformly, again, velocity is constant and object is going back to its starting position from where it has started. Okay, and this line, this curved line represents increasing speed. So if the speed is increasing, what does this indicate? If the speed is increasing, means object is accelerating, velocity is increasing. Because velocity is increasing, so object is accelerating. So in this part of the curve, the object is accelerating. And while this upper portion, this portion, look at the cursor movement. Here we find the velocity decreasing. So because velocity is decreasing, so it is deceleration. Deceleration is retardation. It is negative acceleration. And then it stops because no distance has been covered. In this position, object is at a distance of, tell me, at a distance of, look at this. It's 85 meters. So after covering a distance of 85 meters, it stopped at 10 seconds. No? After 10 seconds. After 10 seconds at a distance of 85 meters. There is no movement in the object. Okay. Again, the line is parallel to time axis. Any doubt in this graph? Should I move to the next slide? Now you have to identify the object of the motion of object. Identify the motion of the object. So we have this graph A. What does this graph indicate? Of course, it is parallel to time axis. So क्या indicate कर रहा है? Object is at rest. Okay. B, graph B. Object is moving with constant speed. Object is covering equal distance in equal time. Third graph, graph C. So graph A represents the object which is at rest. And graph B represents uniform motion. Object is covering equal distance in equal intervals of time. Uniform motion. And here also, it is showing uniform motion. What is the difference between these two graphs? Distance is increasing with time. Distance is increasing with time. We can see. So when we change the distance, when up the time को change कर रहे हो, we are increasing the time interval. The distance is also increasing. While in this graph, we can find initially object is at a distance of 10 meter. At time t equals to 0, let's say 10 meter. Now distance is decreasing with time. Object is coming closer. Okay. It reaches the reference point. And distance of this object from the reference point is decreased to 0. Any doubt? Now what does this graph indicate? This graph indicates non-uniform motion. And here the speed is increasing or decreasing? Speed is increasing with time. And what does this graph indicate? Again, it represents non-uniform motion. Non-uniform motion and speed is decreasing with time. Okay. What does this graph indicate? It is again the same graph, uniform motion. Constant speed. What is the difference between B and F? You tell me. The difference between these two graphs is which has greater speed? B or F? Yes. If we compare these two, the B has greater speed. B has greater speed as compared to F. Okay. Now you know everything. Smart हो गया लड़का हमारा. Distance time graph was speed time graph है. So we have this graph here. So slope of ST graph gives speed. And how do we find slope? Yes, S2 minus S1 upon T2 minus T2. So we have this graph. Now you have to find speed of this. How will you find speed of this? We have displacement time graph. You have to find velocity of this. We have already chosen 2 points here, A and B. Okay. So we have considered the points A and B here. We have to find velocity and we have this displacement time graph. What are the coordinates of point A? We'll write 2 first. Why 2? Exercise is written first. Okay. And what are the coordinates of point B? It's 4, comma 40. Now find slope of this displacement time graph. Slope of displacement time graph gives velocity. So whatever we get is velocity. Okay. So it's 40 minus 20 divided by 4 minus 2. So it's 20 by 2 and answer is 10 meter per second. So this is the slope and the slope is represents slope of displacement time graph is velocity. Do it. Find the velocity using ST graph. A to B, B to C and C to D. This graph is given so we can see that initially this AB represents the inclined line. Okay, it represents uniform motion. Again, we have this line parallel to time axis and then CD. Again, we have another inclined line. Again, it represents uniform motion. So we have to find velocity. So first, we'll consider, you don't know how to do it? Aata hai? Karo? You can choose any coordinates of your choice. See, from A to B, we can choose, yes, it starts from 2, na? So, and this is 0, right? So take abscissa as 2 and ordinate as 0. And here for B, you can take this 5, abscissa is 5 and ordinate is 3. How do we find velocity from displacement time graph? Yes, we take the slope. So velocity or from A to B. We'll take the slope. Okay. So slope of AB. It is equal to y2 minus y1, 3 minus 0 divided by 5 minus 2. 3 by 3. Answer is 1 meter per second. From B to C, velocity from B to C is slope of BC. For this, again, we will find the points, any 2 points on BC. So let's take B and C only. Coordinates of C, 7, 3. Yes. Find the slope. 3 minus 3 upon 7 minus 5. It is 0 by 2, 0 meter per second. Third point, from C to D. What are the coordinates of D? It's 10, 3. Why 3? It's 0, na? 10, 0. Velocity from C to D. We'll find the slope of CD. It is equal to 0 minus 3 divided by 10 minus 7. So it is minus 3 by 3. Answer is minus 1 meter per second. So you can see that here we have positive velocity. And here we have negative velocity. Why negative? Both the graphs AB and CD, they represent uniform motion. This is uniform motion. And CD also represents uniform motion. What is the difference between these two? Here the object is, no, speed is constant. Velocity is constant in both the cases. But the difference is here the object is moving away from the reference point. Distance is increasing with time. And here distance is decreasing with time. Object is moving towards the reference point. It is coming closer to the reference point. Distance is decreasing. And that's why velocity is negative. And here velocity is 0. Object is at rest. That's why this line BC is parallel to time axis. This part of the line is parallel to time axis. Yes. Next we have velocity time graphs, VT graphs. Okay. So for the object moving with constant velocity, we get a straight line parallel to time axis. Okay, as we have for the object at rest, we had a line parallel to time axis. In the same way here also we have a line parallel to time axis. So if we consider the velocity as 10 meter per second, suppose object is moving with a velocity of 10 meter per second. So at time t is equal to 0, its velocity is 10. After 1 second, we see that the velocity is the same. After 2 seconds, again we find the velocity same. So it is not changing at all. Even after a few more seconds, you'll see after 3 seconds, after 4 seconds, we're getting the same velocity of 10 meter per second. It's not changing. It is constant with time. So velocity is constant. Object is moving with constant velocity. Because object is moving with constant velocity and therefore it is not accelerating. If object accelerates only when we have changing velocity. If the velocity is changing with respect to time, then object accelerates. But if the object is moving with constant velocity, then it is not accelerating. So from velocity time graph, we can find two different quantities. How do we find two different quantities from velocity time graph? We can find displacement. Yes. How do we find displacement from velocity time graph? By area under curve. By finding area under curve, we can find displacement. If I ask you to find the displacement in the, suppose consider this time scale only, and if I ask you to find the displacement in 4 seconds, calculate the displacement done by the particle in first 4 seconds of it travel, then how will you find? First 4 seconds में कितना displaced हुआ? So we need to find area under curve. How do we find area under curve? We get a rectangle. We get a rectangle, right? So this is a rectangle. In 4 seconds, we get this rectangle. Displacement is area under curve. Area under VT curve. Area under velocity time curve. Okay, what is the length of the rectangle? Let velocity is in meter per second and time is in second. So what is the length of the rectangle? Length is this 4 seconds and breadth is this 10 meter per second. So we'll simply multiply these two. How do we get area of rectangle? Length into breadth. Length into breadth gives the area, na? So length is 4 and breadth is 10. So it's in meter. Answer is 40 meters. So we can find displacement like this from VT graph. Easy. Now we have to find acceleration. How do we find acceleration from VT graph? Slope of VT graph gives the acceleration. Slope of VT graph gives the acceleration. So we'll choose 2 points. Let this point, consider any 2 points of your choice. Okay, what are the coordinates of this point? 1, 10, and coordinates of this point. The slope is 10 minus 10 divided by 4 minus 1. So we'll get 0 by 3. 0 by 3 is 0 meter. What is the unit of acceleration? It's meter per second square. What is the unit? Unit of acceleration is meter per second. नहीं पता. देखो मैं दोबारा बता देती हूँ. ऐसे क्या बात है? Acceleration क्या होता है? V minus U by T. We measure velocity in meter per second. Okay, and that time is measured in second. So unit of acceleration is meter per second upon second. So we'll get meter per second square. This is how we find units. Okay. Easy. Now please do this. Line. So we had left here the previous class, right? Anna? So for uniform acceleration means for constant acceleration, slope of the graph is a straight line. Constant acceleration, when do we have constant acceleration? when lines, जब line straight हो, when line is straight, बस तब होता है constant acceleration. When we have equal change in velocity in equal intervals of time, then we have uniform acceleration. And from velocity time graph, we can find two different quantities. One is by finding slope and other is by finding area under curve. So if we find slope of velocity time graph, then we get acceleration. And if we find displacement, see, if we find area under velocity time graph, then we get displacement. ठीक है? तो अगर हम velocity time graph का slope निकालेंगे, तो acceleration आएगा. Area under curve निकालेंगे, तो displacement आएगा. ठीक है? V or T को, when we divide these two quantities, we get acceleration. When we multiply these two quantities, we get displacement. जो multiply करके आता है, वो area under curve से आता है. जो divide करके आता है, वो slope से आता है. And how do we find slope? We take 2 points and then we use the formula y2 minus y1 upon x2 minus x1. And here in this particular case on y-axis we have velocity. That's why we have written v2 minus v1 upon t2 plus v1. Any doubt in this slide? Do you want to write this? Have you written already? Yes. Now for uniform retardation, the slope of graph is again a straight line, but there is a difference. You can see. For uniform acceleration and for uniform retardation, graph is different. What is the difference? उसमें ग्राफ ऐसे जा रहा है अपवर्ड डायरेक्शन में, इसमें आप ऐसे जा रहे हैं. इसमें कैसे जा रहा है? Like this. Uniform acceleration and retardation is like this. What is retardation? Negative acceleration. When is acceleration negative? When is acceleration negative? When velocity is decreasing, then acceleration is negative. Okay, so acceleration is negative when velocity is decreasing. So retardation means negative acceleration, and acceleration is negative when final velocity is less than initial velocity. So velocity is decreasing with time. And how is velocity decreasing? In this case, how is velocity decreasing? Decrease कैसा? Uniform and non-uniform. We have equal change in velocity in equal intervals. Still we have equal change in velocity because it is uniform retardation. The word uniform is here. So velocity is decreasing by equal amount in equal intervals. Okay. Okay. Now we can, consider this at time t is equal to t1 seconds. This is the velocity. After some time, this is the velocity. So velocity is decreasing by equal amount in equal intervals of time. That's why the name uniform is there. The word uniform is here. And why retardation? Because it is decreasing with time. At time t equals to, let's say, 1 second. We can take this as 2, 4, 6, 8, and 10. At t is equal to 0, what is the velocity? 10 meter per second. Velocity is 10 meter per second. At t is equal to 1 second, what is the velocity? T equals to 1 second. What is the velocity? 8 meter per second. No? At t is equal to 3 seconds, what is the velocity? 2 seconds, sorry. Let's take 2 seconds first. It is 6 meter per second. And at t is equal to 3 seconds, velocity is 4 meter per second. So we can see that it is, it is decreasing by equal amount. Every time we can see that in 1 second, there is a decrease of 2 meter per second. Every time it is decreasing by the same amount. Because it is decreasing and therefore it is retardation. Acceleration is negative. And uniformly decreasing and therefore the name is uniform retardation. Please write this. For next graph. For non-uniform or variable acceleration. Non-uniform means which is not constant, variable, changing acceleration. The graph is a curve. So here velocity changes by unequal amount in equal intervals of time. Okay, so there is unequal change in velocity in equal intervals of time. So if you draw, take the points here, then you will see that if we take this, at this time interval, velocity is this. At this time interval, velocity is this. So if we take the equal time intervals at this time interval, let's take this as 1, 2, and 3. This is the velocity. So is velocity increasing more rapidly with time? Yes. There is unequal change in velocity in equal intervals of time. So it is non-uniform acceleration. Okay. So we can see that there is more change in velocity. At this interval, we find the change greater. Change in velocity is greater here. Unequal change in velocity. Unequal change in velocity in equal intervals of time. Write this. And non-uniform retardation means, or variable retardation means acceleration is negative. Again, velocity is changing by unequal amount in equal intervals of time. But यहाँ पे unequal amount में कैसे change हो रही है? This is what we have to see. Okay. See, let's consider this as t equals to 1 second. So at t equals to 1 second, this is the slight change in velocity from here to here has changed. Now at t equals to 2 seconds. At t equals to 2 seconds, again, we can see that change is there, but there is more change. Velocity is decreasing more rapidly. Okay, now at t equals to 3 seconds, again, we find velocity is decreasing. At t equals to next second, 4th second, we find change in velocity again. So after every 1 second, we can see the change in velocity. But the change is not constant. Velocity is changing by equal amount. You can see here the change is less, more, and greater change here. Yes, so velocity is changing by unequal amount. So velocity is decreasing. Velocity is decreasing by unequal amount in equal intervals of time. Okay, right. Now tell me. So this is the velocity time graph. We can see various, different variations here. Variations we can see here. So this blue line represents the uniform acceleration. Object is changing its velocity by equal amount. And this represents, this red line is the steady speed, means velocity is constant. In this period of time from 20 second to 40 second, there is no change in velocity. And then from 40 to 50, we can see change in velocity, and velocity is decreasing with time. Earlier, its velocity was 20 meter per second. Now its velocity is 10. Okay, 10 meter per second. So it is decelerating, it is retarding, its velocity is changing, its velocity is decreasing and uniformly decreasing. This is uniform acceleration, blue line. And then this red line is uniform speed. And then we have this green line, it shows uniform retardation. And then we have this curve from 50 seconds to next, this 90 seconds. We have this curve, and this shows increasing acceleration. So velocity is increasing with time here, and velocity is increasing so abruptly. We can see that at 70 seconds, velocity is nearly, between 10 and 15 meter per second. At 80, it becomes between, we can say 20 to 30, right? At 90, it is around 60 seconds, 50, 60 meter per second, right? So velocity is increasing rapidly. So there is unequal change in velocity in equal intervals of time, and therefore the graph is curved. It is non-uniform acceleration. Okay. Now we have these graphs here. Identify the motion of the object. The first graph represents graph A. Tell me. Velocity is fixed at a Yes, this line is parallel to time axis. It shows uniform velocity. Velocity is constant. Yes, velocity is constant. It is fixed. It is not changing with time. And second graph, it is increasing by equal amount in equal intervals of time. So what does this graph indicate? It indicates uniform acceleration. What does this indicate? Uniform acceleration. Graph C, velocity is decreasing by equal amount in equal intervals of time. So it shows uniform negative acceleration. Hai? So what is the name for negative acceleration? It's retardation. Uniform retardation. This graph D. Graph D again shows uniform acceleration. And you can see that at time t equals to 0, object is not at rest. It is moving with some velocity. Can you see this? See, if you look at the first graph, it is constant velocity. And here, constant acceleration, or we can say uniform acceleration. Okay. And acceleration is positive. Velocity is changing by equal amount in equal intervals of time. And this shows uniform retardation, negative acceleration. Okay. And this shows uniform acceleration, the B1, graph B. And this graph also shows uniform acceleration. So both the graphs, this graph, graph B and graph T, they both show uniform acceleration. The only difference is that at time t equals to 0, velocity is 0. Coordinates are 0, 0. At time t equals to 0, velocity is 0 in this graph. But in this graph, we can find that at time t equals to 0, velocity is not 0. So object is not at rest initially. Initially, object is moving. Yes? Initially, object is moving. And here, initially, object is at rest. This is the difference. And one more thing, which graph has more angle? Which graph forms greater angle with x-axis? B or D? I think B makes greater angle. It is, if we draw a line here, horizontal line, then this angle looks smaller and this angle looks greater. It has more slope. If we compare B and D, so graph B has greater slope. Greater slope indicate, see, it's velocity time graph. And from slope of velocity time graph gives acceleration. So greater slope indicate greater acceleration. Okay. And this graph E, what does this indicate? This indicate non-uniform motion, non-uniform acceleration. And non-uniform acceleration, right? And how do we draw the graph for non-uniform retardation? For non-uniform retardation, it's like this. Okay, what does this graph, this AB indicate? Uniform acceleration. And this BC, constant velocity. And this CD, uniform retardation. Or we can say negative acceleration or deceleration. Okay. Now you know all the graphs. Slope of VT graph gives acceleration. Okay. So can you find acceleration from this graph? Find acceleration. How will you find acceleration? Choose 2 points on this graph. What are the coordinates of this point? Let's take this point. What are the coordinates? 0, 20. And coordinates of this point? 4, 80. So we have to find slope, and slope of VT graph gives acceleration. Find acceleration now. Do it. So acceleration is the slope of VT graph is V2 minus V1 upon T2 minus T1. This is how we write. Now put the values. It's 80 minus 20. Haan bolo. On 4 minus 0. We'll get 80 minus 20 is 60 upon 4. Answer is 15. 15 meter per second square. Next, area under VT graph gives. Area under VT graph gives. See, slope of VT graph gives acceleration. Area under VT graph, say we get that quantity which we get on multiplying V and T. So when we multiply velocity and time, we get displacement. Okay, so area under VT graph gives displacement. So can you find displacement in this case from T equals to 0, the area of this shaded portion? Can you find this? So you'll get displacement. Displacement or distance covered by the object in the first 15 seconds of its travel. So 0 to 15 seconds. In this time interval, we can find displacement of the object. How will you find displacement in the first case, case A? How will you find displacement? Just write displacement is equal to, yes, it's area under curve. We'll do area under curve. And what does this curve look like? This shaded region looks like a rectangle. So we can simply write length into breadth. So what is the length? It's 15 seconds. Okay. And this breadth is 4 meter per second. Yes. So length into breadth is 15 into 4. 15 4s are 60. And we measure displacement in meter. In the same way, we can try second part and third part. In the second part, we have, again, we'll write displacement is equal to area under curve. Area under VT curve or VT graph, we can write. Okay. Displacement is equal to area under VT graph. Okay. So how do we find area? This is a triangle. What is the area of triangle? Right angle triangle we have, right? It's half into base into height. Base is 15 seconds and height is 6 meter per second. Okay, so we can write half into base is 15 and height is 6. 2 1s are 2, 2 3s are 6, 15 3s are 45 meter. So 45 meter is a displacement covered by the object. C part, again we have a right angle triangle. So it is right angle at this origin. This is 90 degree. So what is the base? 15. Height is 4. So we can find area under curve. Displacement is, please do this. Displacement is equal to area under VT graph. This is equal to half into 15 into 4. 2 1s are 2, 2 2s are 4, 15 2s are 30. Answer is 30 meter. So now we have ST versus VT graph. We can compare the graphs. So here we have AT graph as well, acceleration time graph. If the object is stationary, it is not moving at all. And in that case, we can see object is not moving, object is at rest. Because object is at rest, so its distance from the origin is constant. Let's take this as 1.5 and distance is in meters. So it's 1.5 every time. At t equals to 0, it's 1.5. At t equals to 1, it is 1.5. At t equals to 2, it is 1.5. So if the object is not moving at all, so speed is 0, velocity is 0, so we cannot draw the graph. Because velocity is 0. Acceleration is 0. Again, we cannot draw the graph, AT graph. Okay. Now, next case is of uniform motion. If the object is changing, uniform motion is if the object covers equal distance in equal intervals of time, or equal displacement in equal intervals of time is uniform motion. So we can see here that at t equals to 1 second, 1 meter distance has been covered. At 2 seconds, 2 meter distance has been covered. So it's a uniform motion. Every time object is covering equal distance in equal intervals of time. So when the object covers equal distance in equal intervals of time, then its speed or velocity is constant. It moves with constant velocity. So we can say that from here we can conclude that velocity of the object is 1 meter per second. So if the velocity is constant, and if we want to draw the same graph in velocity time, then how will we draw? At 1 second, velocity is 1 meter per second. At 2 seconds, velocity is 1 meter per second. So we'll get a line parallel to time axis. Okay? Because velocity is constant. Velocity is constant. So there is no change in velocity. No change in velocity. Delta V is 0. And therefore acceleration is also 0. It is not accelerating, so we cannot draw AT graph. Any doubt? थोड़ा फास्ट तो नहीं करवा रही हूँ. हो रहा है because हमने बहुत अच्छे से कर लिया है already, right? We are only revising. Next is the case when the object is moving with uniform acceleration or constant acceleration. So if the object is moving with constant acceleration, then this distance or displacement, it depends upon square of time. This we'll discuss. When we'll do equations of motion, then you'll get to know. There is one equation of motion that's x is equal to ut plus half at square. And if we assume that initially the object is at rest, then and we are keeping the acceleration constant, it's uniform acceleration, right? Uniform acceleration means we are keeping the acceleration constant. Then position is square of time. It is proportional to square of time. Now because it is proportional to square of time, तो अगर हम time को थोड़ा सा भी increase करते हैं तो displacement में we see the greater change. है ना? अगर आप 1 second से 2 seconds करोगे, you'll find greater change in displacement. Okay, so it's here. Jैसे at 1 it's 1, at 2 we can say it's 4. Okay, it goes like this. So that's why the curve is non-linear. It's curved. Graph is curved. And here, because object is moving with constant acceleration, so it is uniform acceleration. So in uniform acceleration, we have equal change in velocity in equal intervals of time. है ना? So we have equal change in velocity in equal intervals of time, and therefore the graph is like this. And because constant acceleration है, acceleration constant है, इसलिए अगर यहाँ पे आपका acceleration जैसे 1 meter per second है, यहाँ पे 2 meter per second है velocity, 1 second, 2 second. So if we find the acceleration by finding slope, we'll get the acceleration as 1 meter per second square. So here we can draw 1 meter per second square. At time t equals to 0, acceleration is this. At time t equals to 1, acceleration is 1 meter per second square. At time t equals to 2, acceleration is again 1 meter per second square. So every time we are getting the same value of acceleration. So acceleration is constant. So now look at this. This red line represents, distance, and this green line represents velocity. And this pink line represents acceleration. Okay, so it shows uniform acceleration. So for uniform acceleration, distance time graph is a curved line. Velocity time graph is a straight line inclined to time axis. And acceleration time graph is a line parallel to time axis. Next, we have this question. Find the acceleration and displacement using VT graph. We can find displacement for the whole journey from if the object is moving, at time t equals to 0 to t equals to 40 seconds. It's easy to find displacement, right? From 0 to 40, because we can find area under curve. It's a trapezium, so we can easily find the area of trapezium. But for acceleration, we can see that from O to A, object is uniformly accelerating. Acceleration is constant, and we can see uniform acceleration. There is equal change in velocity in equal intervals of time. And from A to B, object is moving with constant velocity. So there is no acceleration. Acceleration is 0 because it is constant velocity. So no change in velocity is there. So acceleration is 0. But from B to C, there is uniform retardation, means velocity of the object is decreasing with time. So we can see that value of velocity is decreasing, and so the object is retarding. So it's uniform retardation. So we have to find acceleration for three different cases. We'll get three different values of acceleration here. And displacement we can find out for the whole journey. Or we can simply add, we can find displacement for from O to A, then from A to B, then from B to C, and we can add, we can do like that only, that also. So there are two ways of finding displacement. Okay. So we'll do by both the ways. So let's write for from 0 to, sorry, origin to A. When the object starts its journey from O and reaches point A, then what is the acceleration? We can choose 2 points. Let's take this point as 0, 0, and this is 10 and 20. How do we find acceleration? We take the slope, and slope is y2 minus y1 divided by x2 minus x1. Yes. So it is 20 by 10, 2 meter per second square. Okay. So this is the acceleration from O to A. So we can also find displacement from O to A. Displacement from O to A, let's write A1 and D1. Okay. So displacement from O to A is area under this OA. Area under OA represents a triangle. It's a right angle triangle. So what is the displacement? Half into, tell me. Base is 10, height is 20. So it is 100 meter. No? 2 ones are 2 and 2 times are 20. It's 100 meter. Similarly, we can find for A to B. From A to B, what is the acceleration? Again, write the coordinates of this point. It's 30, 20. Okay, so acceleration is y2 minus y1 upon x2 minus x1. So it's 0 by 20, and it is 0 meter per second square. Okay, and we can also find displacement. Displacement is area under this portion, and this is a rectangle. So area of rectangle is length into breadth. Okay, so what is the length? It's 30 minus 10, 20. And what is the breadth? It is 20. Length and breadth both are equal to 20, 20, right? So we can write 20 cross 20. It's 400 meter. Now we will take the equation from B to C. From B to C, acceleration is, again, write the coordinates of point C. It's 40, 0. So it's y2 minus y1. So write 0 minus 20 upon 40 minus 30. So it's minus 20 upon 10. So it's minus 2 meter per second square. Okay. And we can also find displacement. Displacement is again area under this curve. It's triangle. So this is 10, base is 10, and this height is 20. So half into base into height. You know? So half into base is 10 and height is 20. So it's 100 meter. Now we can add D1, D2, D3 to get the net displacement. So D is equal to D1 plus D2 plus D3. So what will we get? So we find area of a trapezium. It's half into sum of parallel sides multiplied by distance between parallel sides. This is how we find area of trapezium. Sum of parallel sides. So parallel side is this. These are two parallel sides. Now OC is parallel to AP. Right? So OC is 0 to 40. It's 40 seconds. So 0 to 40. And AB is 10 to 30 is AB. So it's 20. And this perpendicular distance is, the distance between the parallel sides is this. And what is the distance between the parallel sides? It's 20. No? Distance between the parallel sides is 20. So it's area of trapezium O, A, B, C is the displacement, right? No? Area of trapezium is a displacement. So it's half into sum of parallel sides. So 40 plus 20 multiplied by distance between the parallel sides is 20. So 2 ones are 2, 2 tens are 20. It's 40 plus 20 is 60, 60 into 10, 600. So we are getting the same displacement. Okay. So whether you find displacement by taking these different parts, you can find displacement separately or you can find displacement collectively, you'll get the same value. Okay. Yes, let's read the question now. The graph given below shows the positions of a body at different times. Calculate the speed of the body as it moves from A to B, B to C, and C to D. So what we have to find is the speed. Okay, speed of the body. So this graph is VT graph or DT graph? It's a DT graph. How do we find speed from distance time graph? If we have a distance time graph, then how do we find speed? Speed is equal to slope of distance time graph. Yes. Because when we divide distance and time, we get speed. On dividing distance and time, we get speed. Na? So slope of DT graph gives speed. Okay. So first, let's find out for this A to B. From A to B, we have to find the slope. Only then we can get the speed. Okay, so let's choose 2 points. What are the coordinates of point A? It's 2, 0. Abscissa is 2 and ordinate is 0. ऐसे ही है ना? And what are the coordinates of point B? It's 5, 3. So we can find slope. How do we find slope? Yes, it's d2 minus d1 upon t2 minus t1. Slope of dt graph is equal to d2 minus d1 upon t2 minus t. Therefore, speed in this time interval from A to B is equal to 3 minus 2, 0, right? And then 5 minus 2, so it's 3 upon 3. 3 upon 3 is 1. And what is the unit? What should I write? See, it's in centimeter. Distance is in and time is in second. So what is the unit of speed? It's centimeter per second. 1 centimeter per second. So you can see that object is covering equal distance in equal intervals of time. So object is moving with constant speed in this time interval. Now let's take the second part, B to C. From B to C, again, we can find speed of the object from B to C. What are the coordinates of point C? 7, 3. So we will write y2 minus y1. So 3 minus 3 upon t2 minus t1. 7 minus 5. 0 by 2. It is 0 centimeter per second. The object is not moving at all. It is at rest. And we can see that object is, this line is parallel to time axis. And in distance time graph, if we have a line parallel to time axis, then it means that object is at rest. Next. From C to D. What are the coordinates of this point? 9, 7. Again, we'll find sleep by taking slope of dt graph. The slope of dt graph is d2 minus d1 upon d2 minus d1. We have the same formula. 7 minus 3 upon 9 minus 7. 7 minus 3 is 4. 9 minus 7 is 2. It is 2 centimeters. So one more thing, you can see that here in this graph. Look at this graph. See, here the object is moving, again, moving with constant speed, right? Speed of the object in this journey, during this journey from C to D, it's 2 centimeters per second, while here the speed is 1 centimeter per second. In both the cases, from A to B and from C to D, object is moving with constant speed, but different speeds. If you look at the slope, if you look at the angle, this line makes with x-axis or time axis, we can say. So we find that this angle and this angle, look at these two angles. Which angle looks greater? This or this? This angle looks greater. This angle is greater. This angle is greater. It has greater slope. Greater slope implies greater speed. Next question. From the graph, answer the following. What type of motion is represented by AB? What type of motion is represented by AB? AB, it's velocity time graph, right? VT graph hai na? This is velocity time graph. Velocity is in kilometer per hour and time is in hours. Okay. So what type of motion is represented by AB? AB represents uniform acceleration. Uniform acceleration. Next question. What type of motion is represented by BC? Velocity is constant. Yes, it shows constant velocity. Constant velocity means uniform velocity. We can say uniform velocity or object is not accelerating at all, or object is covering equal displacement in equal intervals of time. Acceleration is 0. Yes. Third question. Velocity of the object at point C. What is the velocity of the object at point C? It's 40 kilometer per hour. Acceleration acting on the body between A and B. Can you find acceleration between A and B? Very good. Acceleration is slope of VT graph. Yes. Slope of VT graph gives acceleration. So locate 2 points. What are the coordinates of this point? This is 0, 20. And what are the coordinates of this point? 3, 40. So we can find slope. It's 40 minus 20 upon 3 minus 0. This is 20 upon 3. Or we can write in decimals. 3 6 are 18. 6.67 we can write. It's kilometer per hour square. See, usually we have unit of acceleration in meter per second square. But because here velocity is in kilometer per hour and time is in hours, so we'll write kilometer per hour square. Okay, next. Fifth part. Acceleration acting on the body between B and C. So it is clear that it is moving with constant velocity, so acceleration is 0, but we have to prove it mathematically. So find the coordinates of this point first. It's 6, 40. So acceleration is slope of VT graph. We'll write slope of VT graph. Okay, so it's 40 minus 40 upon 6 minus 3. 0 upon 3. Answer is 0. We can write 0. Okay. Next, acceleration acting on the body between C and D. What is the acceleration between B and C? What are the coordinates of this point? 8, 0. Again, find acceleration. It is equal to slope of VT graph. And what type of motion is represented by this CD? It's uniform retardation. Very nice. Learn ho gaya अच्छे से. Slope of VT graph. So it's 0 minus 40 divided by 8 minus 6. Now you will get your acceleration negative because it is retardation, na? So you'll get the value negative. So it is minus 20 kilometer per hour square. Okay, next, total distance traveled by the body in 8 seconds. 8 seconds means from here. What is the distance traveled? How will you find the distance? Total distance traveled by the body in the first 8 seconds. Should I clear this? See, we can, just join this. So this is a trapezium. Mark this point as E. And this is a right angle triangle. Yes, mark this point as F. If we have to find distance traveled, how do we find distance from VT graph? Distance is area under VT graph. Area under VT graph. Okay. And area under VT graph is area of, this portion. This portion and this portion. So we have 3 different figures here. So area of trapezium, we can write area of trapezium A, P, C, E plus area of rectangle O, A, E, F plus area of right angle triangle D, E, F. So how do we find area of trapezium? Okay. We need to write the measurement now. First we will write the measurement, only then we can find. Okay, so what is the length? AE. It is equal to 7 hours, isn't this is 7, and this BC is, it starts from 3 and ends at 6. So it is 6 minus 3. You can write 3 because it is 6 minus 3 on x-axis. If you see on time axis, and it's 6 minus 3. No? Yes. And distance, this is 40 minus 20. So it is 20. So how do we write area of trapezium? Sum of parallel sides, matlab 7 plus 3 multiply by distance between the parallel sides is 20 plus area of rectangle. It is 7 and breadth of the rectangle is 20. So 7 into 20 we can write because length into breadth is the area of rectangle plus area of triangle is half into base into height. Half into base is 1, height is 20. Base is 1 and height is 20. Okay, now solve this. So half into 7 plus 3 is 10 into 20 plus 7 to twos are 14, 140 plus 2 ones are 2, 2 tens are 20, we get 10 here. 2 ones are 2, 2 tens are 20, 10 into 10 is 100. So it's 100 plus 140 plus 10. So it is 240 and 250 kilometer. Why kilometer? Because velocity is in kilometer per hour and time is in hours. We'll get our displacement in kilometers. Okay, this is how we do. Any doubt? Yes, sir. Tough था या लेंदी थे? टफ यहाँ पर आ गया, लेंदी भी था. अगर ये क्वेश्चन आप कर लेते हो ना ग्राफ का, तो मतलब आप ग्राफ के क्वेश्चंस कर लो. आपका ये इसी लेवल के क्वेश्चंस आते हैं एग्जाम. ठीक है, इससे आप ऊपर नहीं होगा ग्राफ में. तो आई गिव यू असाइनमेंट, देयर यू विल फाइंड अराउंड 10 क्वेश्चंस. ऐसे सिमिलर टाइप ऑफ क्वेश्चंस यू विल गेट. उसको प्रैक्टिस करो तो ये बेटर क्लियर हो जाए. एनीथिंग यू वांट टू आस्क इन ग्राफ्स? एनी डाउट? VTDT कहीं पे भी, स्लोप में, एरिया अंडर कर्व में, कहीं पे थोड़ा सा भी डाउट है? सब कुछ क्लियर है? ग्रेट. Now write the solution of this question.